Can you imagine what such a volcano must have looked like to our ancestors?
Welcome to a new episode of Geoscopy. Cool that you're here. Have you ever wondered about the sheer power of volcanoes? Volcanoes are not only one of the most awe-inspiring natural phenomena on Earth, but also the most destructive, as you will see. In this short video, we will explore different types of volcano and how they've impacted our world and history.
Many hunters and gatherers, they lived in the great shadows of our volcanoes. Each generation passing by had a story about the angry mountain. Now, of course, they didn't know what we do today, that the Earth was going through long cycles of warming and cooling, so all they could do in the face of them was to run away. We feared volcanoes. Indeed, our emotions were shaped through the dread of them erupting, reminding us of life's fragility.
You guys have seen volcanoes. Maybe in person, they offer some of the most commanding shapes in nature, along with mountains, trees and stars. If we as humans are part of nature, then surely volcanoes are also part of us. As we have wondered at their beauty, often stupefied in their presence, our understanding of the harsh realities of life have been tutored by their wrath. For example, a volcanic super eruption at Yellowstone 630,000 years ago, so yeah, quite some time ago, covered half of the continental USA with ash. Now, an eruption in Sumatra by Lake Toba 75,000 years ago caused land temperatures to drop globally by up to 15 degrees Celsius and oceans by up to 6 degrees Celsius. Such catastrophic events brought the human race to the very edge of extinction, at one point reduced to a global population group of less than 4,000 individuals. That's more people that donated to Wikipedia in the last 10 years.
The eruptions of the early 17th century had some major consequences on European agriculture, causing widespread starvation. Switzerland experienced some of the lowest temperatures of them all. The Romans had their own volcano too. Mount Vesuvius, on the shores of the Bay of Naples, erupted first in 1780 BCE and then again, much more violently, in 79 AD.
The Romans were the first to have some understanding of the dangers and tried to predict and react to the tremors they sustained. The philosopher Seneca wrote a few years earlier where he speculated about volcanoes and their effect upon the weather, more like a geologist really. Yet the calamity of Vesuvius was even greater than Seneca had imagined.
Engulfed by a plume of its hot toxic gases, the Rome philosopher Pliny was not so lucky. He managed to write before dying, "There is miserable but mighty consolation that all humankind is now involved in the same calamity." The fall of Constantinople in 1453, the English colonization of the northern United States, and the outbreak of the French Revolution all have been linked to volcanically generated climatic events.
Volcanoes are erratic. They have their own power laws, making them extremely difficult to anticipate. Although any volcanic eruption falls within two types: diffusive, which occur when exceedingly hot, flowing basalt magmas reach the surface and then flow readily downhill as lava.
And then there are the explosive eruptions, which occur when cooler, more vicious magmas reach the surface.
In this type of eruption, dissolved gases cannot escape as easily. Pressure builds up until a massive gas explosion blasts rock and lava fragments high into the air. These lava flows are much more thick and do not flow downhill so easily.
One of the most recent and most destructive volcanic blasts occurred as recently as 1980. It all started with ominous rumblings, followed by the erupting magma. The earth surrounding Mount St Helens started to shake with the force of a major earthquake. The massive fireworks spectacle at its summit quickly became a feast for naive eyes as TV crews, reporters, helicopters swarmed around the molten crater.
People climbed the mountain even as its northern flanks began to bulge ominously. Incredibly enough, scientists miscalculated its potential impact and failed to assess the possibility of an alternative kind of blast basing their projections on the standard Hawaiian volcano model, you know, the one with the effusive eruptions. Now this was an odd thing to do in retrospect because there are fundamentally three types of volcano. The classic composite volcano, which is the type most of us think of when imagining volcanoes. With broad bases and sides that gets steeper and steeper as you get closer to the top. When a composite erupts, it ejects a pyroclastic material high into the air, which then settles back down on the earth. Or the shield volcano that doesn't have the steep mountainous sides, but instead very wide bases and flatter tops. Although they are not steep, they can be very large. The magma that creates shield volcanoes is also less viscous and flows down more easily. For this reason, the eruptions of shield volcanoes are largely non-explosive. Then there is the smallest category, the cinder cones, the most common type. They rarely reach 300 meters in height but have the steepest sides. But then there was a new category out of its own, Mount St Helens.
Only one scientist knew something bad and unusual was about to happen.
Jack Hyde was a geology professor from Tacoma in the US. He noted that Mount St Helens didn't have an open vent, and so any pressure building inside the volcano was bound to be released, and predictably, and he was right. On the 18th of May at 8:32 AM, the whole side of the volcano collapsed, sending an enormous avalanche of dirt and rock into the air. The biggest landslide in human history, enough to bury New York City to a depth of 120 meters. And then, when Mount St Helens did finally explode, it was with the force of 27,000 Hiroshima-sized atomic bombs, firing a murderous hot cloud at over 1,000 km/h deep into the Earth's atmosphere. An airliner over 48 kilometers away reported being pelted with rocks.
Scientists and volcanologists hopscotch around the world. And today, there are many specialized fields surrounding our understanding of volcanoes involving complex plate theories.
All agree that the buoyancy of the magma, the pressure from the expelled gases in the magma, and the injection of new volumes of magma in the already filled magma chamber causes the great explosions that we all witness in classic volcanoes, like the one at Mount St Helens.
Volcanoes are sufficiently complex to still give us pause, even today. As political leaders bicker and argue, we all know that in the background sits the mighty volcano, whose ferocity might reshape and restructure our global priorities from one second to the next. To this day, they are the bomb that sits beneath our feet. Thank you for watching Geoscopy and enjoy the view.